Assalamu alaikum and very good morning. This is Dr. Rafi Afroz from Department of Economics, Faculty of Economics and Management Sciences, International Islamic University, Malaysia. Today, I'm going to present the research paper entitled Climate Change and Rice Production, Empirical Investigation from Malaysia. And the co-authors of these articles are Prof. Jarita Duasha and my PhD student MD Muhibullah. Malaysia, being a developing country, faces tremendous challenges in its agriculture business. So the agriculture sector, its contribution to the country's GDP, it was 43.7% in 1960, but it fell to 8.02% in 2017. So this appears to be contradictory given the country's agricultural land increased from 9.4% in 1961 to 26.3% of the total land area in 2015. So rice is the staple food for the majority of the world population, and it is consumed by around 3 billion people. So approximately 90% of the world rice is produced and consumed in Asian country, and rice it is the Malaysia's second most important food crop behind wheat. It is critical to the country's agricultural economy, that's why. And despite its teeny contribution to the nation's GDP, the paddy and rice business has piqued the interest of the policymakers due to its complicated link with food security, culture, and socioeconomic concern. So in this figure, it is very clear that why nowadays rice production is in Malaysia, it is, attracting attention of the policymakers, because from this figure, you can see that there is basically the national rice demand, it is increasing with the steady harvest area size. So, and in figure 2, you can see that there is basically, growing disparity between the Malaysia's rice consumption and the production. So, and also you can see that, Malaysia's is always now they importing rice from other countries. So that's why we need to, be self-sufficient in rice production in Malaysia. So now we can see that agriculture, this is the very important component of Malaysia's economy, and it produced 12% of the national GDP and employing 16% of the total population and improving living in rural area via different activities in the agricultural sector. So, but there are many studies in Malaysia. They have investigated that the climate change, it is basically affecting the crop production, and they found that climate change has a negative impact on the agricultural sector. So climate change, according to Tang 2019, has had an influence on Malaysian agriculture industry due to rising temperature and uncertain rainfall variability year after the year. So extreme weather conditions such as flood, drought can impact agricultural crop rice like the rice production. For example, Masood and another study that is conducted by Herad, they found that the temperature and rainfall, they actually impact the rice production in Malaysia, and they observed that temperature and rainfall both, they had a detrimental impact on rice production. So only a few studies we see that they have combined the climate change and economic consideration into the to explain the rice production. So that's why this study we are combining the climate change factor and also the economic factors in order to see how they affect the rice production in Malaysia. So climate change variables, for example, carbon dioxide emission and temperature, and economic variables, they should actually explain the influence of climate change in Malaysian rice production. So now in the next slide, we will discuss the econometric methodology. So the objective of the study is to investigate the link between some relevant factors. So in this study, the dependent variable is rice production And independent variables include the climate factors, for example, carbon dioxide emission and average temperature. This study also look into the additional economic factors, for example, rice crop, like area under the rice crop production and fertilizer use. So annual time series data for rice production, rice crop area, fertilizer usage from 1980 to 2018 are derived from various sources. A realistic approach for the empirical investigation is required to explore the effects of climate change on rice production. So that's why the study employed many econometric techniques. For example, here when we check the stationary of the variables, so we employ ADF, PP, and KPSS. And also we use the ARDL limit testing approach for co-integration. And then lastly, we check the model's stability test using the Cushom and Cushom square test. Okay, so lastly we do the conclusion and policy. The autoregressive distributed lag model. This is very much popularized by Pearson, which has many advantages as associated to previous co-integration approaches like as e.g. maximum likelihood based test by JJ. So for checking the presence of long-run association by the ARDL approach is easy without considering the series which are stationary at level like I0 or stationary at first level I1 or combination order of the integration. So the ARDL approach, as it is very much reliable in case of small sample size, and it can avoid the issue of endogeneity, and it also helps to investigate the coefficient in the long run. So ARDL F test, okay, it is basically used to examine the presence of the long run association between the selected study variables. So this is our model, and this is our a null hypothesis that whether there is long run association among the variables or not. So this table, it is basically presenting the descriptive statistics of the variable that are used in my study. Based on the results of the Jarko-Bera statistics, all variables are found to be distributed normally, and they have constant variance and zero covariance. And likewise, this table, it reports the correlation matrix, and it is showing that there is closest positive correlation between carbon dioxide emission and rice production, followed by fertilizer consumption, average temperature, and area harvested. In this table, you can see that we use ADF test, PP, and KPSS test in order to see the stationarity of the variables. And then the result of this table, it is showing that carbon dioxide emission, average temperature, and area under rice production are stationary at level where rice production and fertilizer consumption are integrated of the first order with intercept. So we can apply the ARDL approach. And this table 6, it is presenting the ARDL bound testing approach. So from this table, we can see that our F statistics is 5.63, which is exceed like the upper bound limit at 10, 1, and 5% level of significance. This result implies that there is a long-run relationship among the variables when rice production is used as the dependent variable. In addition, the estimated outcome of the various diagnostics tests you can see in this table 7, it revealed that error terms of the specification of the ARDL bound test for co-integration model are normally distributed, and the residual free from heteroscedasticity and serial correlation. So now in the next slide, we can see the long run and short run estimates. So this table is showing the long run impact of carbon dioxide emission, average temperature, harvested area, and fertilizer consumption on rice production in Malaysia. And from this table, we can see that the carbon dioxide emission in Malaysia have a positive and significant impact on rice production. So the long run coefficient of carbon dioxide emission, it demonstrates that at a 5% level of significance, a 1% rise in carbon dioxide emission result in a 0.17% increase in the rice production in Malaysia. So this result is consistent with another study which is conducted by John Jua in 2014. They also found that carbon dioxide emission has a positive impact on rice production. In contrast, in the short run, you can see the coefficient of carbon dioxide emission has a detrimental impact on rice production. So the coefficient of short run, carbon dioxide emission demonstrated that a 1% rise in carbon dioxide emission, it reduced the rice production by 0.19%. And similar to our result, Amponash ETL 2015, they also observed that there is negative relationship between carbon dioxide emission with cereal production in the long run and short run. So and also Janjua in 2014 explored that climate change factors, including carbon dioxide emission, average temperature, average precipitation, have positive influence on wheat production in both long run and short run in Pakistan. So now, if you look at the other variables, for example, rice production, it is positively impacted by the area under cultivation in the long run and short run. So a 1% increase in cultivated area or harvested area is predicted to result in a 2.13% and 2.92% rise in rice production in both long run and short run respectively. So and also fertilizer intake, it you can see it is shown to have a detrimental influence on rice production at 1% significance level in the long run. The coefficient of fertilizer, it shows that a 1% increase in fertilizer usage is predicted to reduce rice production by 0.12%. Actually, this is maybe indicating the overutilization of the fertilizer in case of rice production. So that's why we have to use efficiently fertilizer use in case of rice production. So that's why we have to be very careful now. But in surprisingly, in the short run, it is showing a positive impact in a positive impact of fertilizer use in rice production. So in the short run, it is showing that if there is 1% increase in the fertilizer use, it will increase the rice production by 2.32%. And this is actually similar with other study. For example, Hussein and Janjua, they also found a similar result. However, lastly, you can see the temperature. It is showing that 1% increase in temperature, it reduces rice production by 7.86% and 2.63% in the long run, short run. So, and lastly, we can see that DCCM, it is it is almost like 0.70, and it indicates that adjustment occurs at a rate of 0.70% per year toward the long run equilibrium. And lastly, the R square and adjusted R square, it is calculated to be like 0.80 and 0.82% respectively, which argues that our model is well fitted. In addition, the result, which is shown in this table, we also prove that the estimated model has passed all diagnosis tests that we see in the last slide. Also we can see that this model also passed the stability test, which we see in the previous slide, as evident by the graph of the recursive residual. So and now the next slide, the conclusion. Okay, this paper investigates the impacts of climate change on rice production in Malaysia by utilizing annual time series data from 1980 to 2018. And the estimated outcomes show that there is long-run association among the climate change factors, including carbon dioxide emission and average temperature, and with other variables, which is like rice production, usage of fertilizer, and then the area under rice production. And then the result of ARDL shows that carbon dioxide emission and average temperature has a positive impact on the rice production in the long run, but they have negative impact in the short run. So that means from here we can find that the climate change is affecting the rice production in Malaysia. So the government can support the rice farmers in order to tackle this climate change. But recently Malaysian government, they are taking various kinds of initiative in order to tackle this climate change. Okay, and then that means they should increase the adaptability practices, okay, at the farm level. So and also the government, they can boost the capacity of the scientists and agricultural staff to develop and promote the appropriate and effective technology to help the farmers to adapt with this climate change. Okay, so and also from our result we find that area under cultivation has a positive influence on rice production both in the long run and short run. Lastly, fertilizer utilization has a negative influence in rice production in the long run, but it has a positive influence on the output of the rice production in the short run. So from here we found that the fertilizer utilization, it is not efficient. That means the farmer, they are not efficiently using this fertilizer. So that's why they should should be given the information like how to utilize this fertilizer efficiently. So maybe the agriculture staff, like the agriculture extension officer, they can help the farmer in this case. Okay, finally we can say that further research is recommended to assess the feasibility of the farm level adaptation practices to climate change. So because this can help the government, researcher, non-government organization, policymaker and farmers to develop and implement adaptation measures that are sustainable, resilient and reliable. Okay, thank you very much.